we are giving the AC signal in non-inverting terminal. We are giving it through a resistor. Sorry, signal we are giving it to inverting terminal. Non-inverting terminal we are making it to ground. Then we are having diode elements, switches. Under switch you will have diodes. So there are two diodes. One diode will be as a feedback, another diode will be in the output. Then we will have one resistor. So these are the components. To see the output, there is in the bottom, hope you can see the screen. In the bottom, if you connect it, there is a voltage probe. You have to see the input as well as output. So two voltage probes are connected. Similar to voltmeter, here voltage probes are connected. Hope you can see the screen clearly.
Yes, ma'am.
Okay. So input signal, default it will be 110 volt, peak to peak. Peak amplitude is 110. So total size will be 220. So here we will give 5 volt, 5 volt, and the probe we can change the name, it is input. Input, we'll display that, and the resistors we will default give it as 1K. Diode we have used as normal diode, but the voltage drop we have set it as 0. For silicon we can set it as 0.5, and for germanium we will set it as 0.3. So here I'll set it as 0.3. And this resistor 2K, and this diode also will set it as 0.3 voltage drop. So this is the output voltage probe. We will click it and give that it is the output, V out. So very simple to know the operation. And here two diodes are there, D1 and D2. We know that when positive signal comes, D1 will be on. Since it is given in an inverting amplifier, when the signal comes near D2, it will become inverted. Positive cycle will become negative cycle near D2, and D2 will be in off. Therefore, output voltage will be 0. So when positive cycle, output voltage is 0. Negative cycle, it will invert and we will get the positive cycle. We'll give input, output together, we will view that. Here there is a small, here the mistake is, hope you can see the waveform, the mistake is the x-axis we are having it in 10 millisecond. We have to increase the x-axis so that we will able to see the output. Here we can give the frequency. Frequency and time are inversely proportional. If we increase the frequency here, default it is 60 hertz. So 60 hertz means time will be less. If time will be more. If we increase the frequency, time will become less. So I'll give it as 500. We will see whether it is coming within the window which we are viewing the signal. Frequency low means time high. Frequency high means time is less. Hope you can see the waveform. What happened? Positive cycle, the output is 0. Negative cycle, it becomes positive same. And if you give the both resistors same, here actually both resistors are different, Rf by R1. So it is multiplied by 10 times. Sorry, Rf by Ri. So there is a multiplication. I'll give it both the same, 1K. Then we will run the simulation. If both are same, there won't be any amplification. If both are Rf is greater than R1, there is amplification. If Rf is less than R1, then the amplitude will be reduced. So in the previous case, it is amplified. Here, no amplifications. So both the resistors are same. Positive half cycle, the output is 0. Negative half cycle has become positive half cycle. So this is half-wave rectifier. Positive half cycle D1 will be on, D2 will be off. Negative half cycle D1 is off, D2 is on. So the negative cycle will get in. And if we want to amplify the output, RF, this feedback resistor value should be greater than the input resistor. If we want to, no need to amplify means this resistor should be greater. Hope you can see the difference. Here you can see the amplitude is reduced. So if you want to reduce the amplitude, this R in resistor should be greater than RF. If no need of any amplification, just we need only half cycle means both the resistors should be same. Everyone understood the impact of resistors, feedback resistor and input resistor? If both feedback and input resistors are same, there is no amplification in the output. And if the feedback resistor is greater than the input resistor, I'll write it here, input resistor, and this is feedback resistor. Feedback resistor. So if feedback resistor value becomes greater than the input resistor, then the output, you will get an amplified output. The rectified signal, we will get rectified, the signal is rectified and amplified. Clear? Half-wave rectifier circuit? Anybody having any doubt in this? So if you have any doubt how the resistors impact the output, you can put it in the simulator.